final 2020 part 2. Okay, so here we got rational equations. So that means you guys have to multiply the whole thing by the LCD. So the LCD of this is x plus 5. Alright, x plus 5. So that means you need to multiply every single term by x plus 5. Alright, so when you guys multiply this one by x plus 5, the x plus 5s are going to cancel, which means you only get a 1, because that's the numerator, right? Okay, when you multiply x plus 5 times this one, nothing cancels, so all you're going to get is x plus 5. When you guys multiply this one by x plus 5, the x plus 5s will cancel, which means the remainder is just a numerator, so x squared plus 13x plus 42. Now, when you guys have this, just set it equal to 0 and then solve for x. So we're going to get x plus 6 on this side because 1 plus 5 is 6. Going to subtract x from both sides. 13x minus x is 12x. And subtract 6 from both sides. Okay. Now we just factor. I'll just display it. Two things that multiplied are 36, but add together gives you 12 is 6 and 6. So x plus 6, x plus 6. And then set both of them equal to 0, and we're going to get x is equal to negative 6. Now, to check, just make sure you substitute it back into the original equation, and make sure you do not get a 0 in the denominator. Oh my gosh. So, negative 6 plus 5, negative 1. So we are clear. So that means D would be our answer. Alright, next one. Okay, so do you guys see this one? I see that you can factor out an n from the denominator. So that one's factored, and this one you can factor out an n as well. Okay, so that would be our equation. So then your guys' LCD for this problem would be n times n minus 5. So that's what we're going to multiply the whole thing by, n times n minus 5. All right. Oh, let me show my arrows. Okay, so when you multiply that one to this whole one, right, n times n minus 5 times that one, both of these would cancel, which means that you would just get a 2. Now, when you multiply this to this one, only the n's would cancel. So then remaining, right, it looks to be just n minus 2 times n minus 5. Equals, multiply n times n minus 5 to that one, the denominator and this one would cancel, so all you're left with is 6. And then from here, you guys just set it equal to 0 and solve for n. And so we're going to get 2 plus distribute, right? We got to distribute this. N times n squared, n times negative 5, negative 5n, negative 2 times n, negative 2n, negative 2 times negative 5 plus 10 is equal to 6. So we're going to get n squared minus 7n plus 12 is equal to 6. I just combined 2 and 10 to get 12, and these two combined gives you negative 7n. Subtract 6 from both sides. N squared minus 7n plus 6 is equal to 0. Factor 6 and negative 7. Two things that multiply to 6 but add together gives you negative 7, negative 6, and negative 1. So n minus 1, n minus 6 equals 0. So n is going to give you guys 1 and 6. Go back to the original and make sure that when you substitute 1 and 6 that the denominators are not equal to 0. So that and that looks to me, if you plug in 1 or 6, none of them is 0. So answer is just going to be A. Alright, moving on. Okay, so in rational, so these ones are transformations. Now, when you guys have a negative function of the rational, when you have negative rational functions, most likely it's going to be in quadrants 2 and 4. So just from that, I know it can't be that because those graphs are not in quadrants 1 and 3. That's in quadrants 1 and 3. Well, I'll write down the information and then we'll just go from there. Alright, so since it's negative, that means it's going to be in quadrants 2 and 4. Quadrants 2 and 4. And the vertical asymptote is when you set the denominator equal to 0. So right there, that's going to be at x is equal to 2. That's one vertical asymptote, and this tells you guys the horizontal asymptote. So horizontal asymptote is y is equal to 1. So let's just look for a graph where it's in quadrants 2 and 4 and has vertical asymptote at 2 and horizontal at 1. Looks to be that one, right? Horizontal asymptote at 1 and vertical asymptote at 2. If you guys were to go down the list, this one's in 1 and 3, so that wouldn't be it. That's also in 1 and 3, that wouldn't be it. This one is in quadrants 2 and 4, but then it has a horizontal at 2 and a vertical at 3, so it can't be that one. Okay, alright, that's a positives function, so you know it's going to be in quadrants 1 and quadrants 3. The vertical asymptote, set the denominator equal to 0, so it's going to be at x is equal to 2. Horizontal asymptote is y is equal to 1. So you know it's in quadrants 1 and 3, and vertical asymptote of 2, horizontal at 1. Va and ha, right? K, A, that's in quadrants 2 and 4, so that cannot be it. B, that's also in quadrants 2 and 4, so that can't be it. C, quadrants 1 and 3, looks good. Vertical asymptote at 2, though. Is that what we wanted? That is what we wanted. And horizontal asymptote at 1. Looks to be C. Alright. Alright, so for this one, you guys, hold on 1 second. I want to see how the download's going. 9 minutes to go for the first part. Great. Alright, so for these, you guys just have to factor out everything, and then we'll get information from there. So the top factors into x minus 2 and x minus 4. If you want to see that, it looks like this. 8 on top, negative 6 on bottom. Two things that multiply to 8. Add together gives you negative 6. That is and would be negative 2 and negative 4. Next. Alright, I automatically see I could factor out negative 3 from each term. So negative 3 divided by negative 3, 1, so just x squared. Negative 6 divided by negative 3 is plus 2x. 9 divided by negative 3, negative 3. So now all we would have to do is factor out that part, right? Negative 3 on top, 2 on the bottom. Two things that multiply to negative 3, but add together gives you 2. That's 3 and negative 1. So negative 3, x plus 3, x minus 1. So we factored out everything, And now we can find all of our vertical asymptotes, horizontal, and holes if necessary. Okay, vertical asymptote is when you set the denominator equal to 0. So we would get x is equal to -3 or x is equal to 1. Horizontal asymptote. So you guys look at your highest degrees, and then from there you can decide. So in the numerator it's 2, and the denominator it's 2. If they have the same highest degrees in numerator and denominator, all you guys have to do is look at the coefficients. So since they're tied, 1 over -3 is simply y is equal to -1/3. Now let's look for a graph that has vertical asymptotes of -3 and 1 and horizontal asymptote of -1/3. Well, this does have two vertical asymptotes, but if you guys take a look, those vertical asymptotes look to be at 0 and 3, which is not ours. Gone. B, this one doesn't have two vertical asymptotes, so why bother? C, this one has two vertical asymptotes, but it's at 2 and it's at 4, which is not what we wanted. So then if we look at D, vertical asymptote at -3, good. Vertical asymptote at 1, good. And a horizontal asymptote at -1/3. That one looks very good, D. Alright? Okay, 29. Remember, factor first, right? So, we're going to get x plus 4 and x plus 1. If you want to see me do that, 4 on top, 5 on bottom. Two things that multiply to 4 and add up to 5, it's 4 and 1, so that's how I got that. Now for the bottom, you can factor out an x from both, so x plus 1. Now, notice you guys can cancel, right? So when we cancel, that means we're going to get a whole at x plus 1 is equal to 0, which means x is going to equal -1. This is where you guys get a whole. So after you guys cancel, you would get something like this. And the vertical asymptote would be when you set the denominator equal to 0, set x is equal to 0. And your horizontal asymptote, both of those have the highest degree of both 2. So that means the coefficient, so you look at the coefficients would be 1 over 1, which is just simply 1. So let's first look for ones that have a hole, and then we'll just go down our information slip. This one has a hole at -1, right? X equals -1 on this line right here. So that one has a hole. It has a vertical asymptote at 0. And it looks to be, it does have a horizontal asymptote at 1. So it's actually A. Now, knowing that you guys have a hole, right? I would automatically, if you didn't know if it was A, I would just automatically look for ones that have a hole. That one doesn't have a hole, and that one doesn't have a hole. That one does have a hole there, so then choices would be between A and D. Then I would look at horizontal asymptote of 0. It's A. Look at this one. This one has a horizontal asymptote at -4. So use your guys' information, right, to get rid of multiple choice answers. That will give you guys the best possible choice. Okay? 30. Same dealio. Let's figure out what we can factor. We got -2 on top, 1 on the bottom. Two things multiply -2, but add together gives you 1. That seems to be 2 and -1. So x plus 2 times x minus 1 all over. Okay, so denominator, I see that you can factor out a 2x from every single one. So we're going to get x squared plus 2x minus 3. And then on the bottom, if you guys factor out that piece, -3 and 2, which would be 3 and -1. 3 times -1 is -3, but when you add them, gives you 2. So 2x x plus 3 and x minus 1. So we factored out everything. Now, I noticed we could cancel those, so that means x minus 1 equals 0, x is equal to 1. That means we're going to get a whole there, okay? What you cancel is where you guys get a whole. Now, if you guys set the denominator equal to 0, this one, that 2x, would give you x is equal to 0, and this one would give you negative 3. Horizontal asymptote, we will look at the original. Now notice, 2 is less than 3. If the denominator is less than the degree in the numerator, then the horizontal asymptote would be at 0. So, let's just look for wholes at 1. So, A has a hole at 1, so that one's okay. This one has a hole not at 1, so we're going to cross that off. This one does not even have a hole. And this one does have a hole at 1. So between A and D. Now let's just look for vertical asymptotes that have 0 and negative 3. Well, this one has 0 and negative 3. So a good strong hunch that it's probably going to be, oh my gosh, A. And it has a horizontal asymptote at 0. Now if you guys took a look at D, this one, come on, lag. This one does not only have a vertical asymptote at negative 2, so it can't be that. Okay, 31. All right, the leading coefficient's a negative, so we don't like that. So we're gonna factor out a negative 1 from the bottom. So we're gonna get x squared plus x minus 6, and now I'm gonna factor out that bottom piece. So negative 6 on top, 1 on the bottom. Two things that multiply negative 6 but gives you 1, 3, and negative 2. So we're going to get 1 over negative 1 out of x plus 3, x minus 2. So I'm going to get a vertical asymptote at x is equal to negative 3 and 2. And horizontal asymptote, look at the degrees. Well, this has 0 degree because there's no degrees, and this has a 2, which means horizontal asymptote at 0. Y is equal to 0. So let's look for vertical asymptotes at negative 3 and 2. This has 2 vertical asymptotes, but it's not at negative 3 and 2, so cross that one off. This one has vertical asymptotes at negative 3 and 2, and it has a horizontal asymptote at 0. So it's probably going to be that one. But if you guys were to no, that one didn't have vertical asymptotes. This one only has 1. So your answer is B. Alright, so moving on to 32. So when you guys do this one, okay, remember, when you guys have a fraction that's an exponent, the denominator is the root. Okay, the denominator is the root. So if you were to change this power to be a root, it would be the cube root, because remember, the denominator is the root. Cube root of 125n to the third. And then we just make our lovely tree. Finding groups of 3, right? That's what the root tells us. So we found one group of 3 of 5s, which means 1 5 comes on the outside. And then remember, for the powers or exponents, this root of 3 goes into 3 once, which means 1n could come on the outside. So 5n. 33. Remember, the denominator is your root, or the root is the denominator. So if we were to put this as a root, it'd be cube root of 8x to the third in parentheses to the fourth. So this is 4 and 2, 2 and 2. We found a group of 3 of 2s. So a 2 gets to come on the outside, and 3 goes into this 3 once, so that means 1x to the fourth. 2 to the fourth is 16, x to the fourth, x to the fourth. C. 24. Okay, so 1 over, remember, the root is the denominator for the exponent, right? So p to the 4/3. So, usually you guys don't like to have, well, basically, an equivalent expression is if you get this p to be in the numerator. So to make this go in the numerator, you just take the opposite of your degree. So it'd be a. 35. Remember, the root is the denominator, so that means this is just 3b to the 4/3. All right, 36. Okay, so I'm gonna rewrite these because I think we have to in order to show our work. All right, root 2 and root 2, those both look like we don't need to touch them. So these ones we gotta factor 4 and 2, 2 and 2, 9 and 5, and 3 and 3. So pair of 2's right there, pair of 3's right there. So remember, those get to come on the outside of the root. So -3, because that's already on the outside, times 2, square root of 2, because that's a leftover, right? Plus 2 rad 2, minus, okay, this 3 gets to come on the outside, right? So -2 times 3, leftover is 5, so square root of 5, minus root 2. So if we simplify this, -3 times 2, -6 rad 2, 2 rad 2, -2 times 3, -6 rad 5, minus root 2. So combine like terms. You can combine like terms for roots if they have the same root and radicand. This one, that one, and this one all have the same root and radicand, so we can combine those. -6 plus 2, -4, but -4 minus 1, -5 root 2 minus 6 root 5. A. And let me take a peek at how my download's going, and it's still going. All right, 37. Let's write them all down. So -3 root 3 plus 2 square root 27 minus 3 square root 20 minus 2 square root 18. So, gotta factor all these out. Okay, 27, 9 and 3, 3 and 3, there's a pair. 4 and 5, 2 and 2, there's a pair. 9 and 2, 3 and 3, there's a pair. Alright, so this one's are already simplified, so no need to worry about that one. Okay, so we found a pair of 3's, right? So that gets to come on the outside. Now there's already a 2 out there, so we just gotta do 2 times 3, which is 6. Root 3, because that's a leftover. That one's done. Next, so we got a pair of 2's that we found, so 2 times comes on the outside, so 2 times -3, -6, root, leftovers, it was the 5. So 5, unfortunately, has to be on the inside. And then the last one, we found a pair of 3's, so that means 3 times the outside. 3 comes on the outside, and 3 times -2, which is just -6. Remainder, 2. Now, collect like terms. So this one and this one have the same radicand and same root, so we can combine those. So 6 minus 3, or -3 plus 6. 3 root 3 minus 6 root 5 minus 6 root 2. 3 root 3. There we go. C. Alright, 38. Now, when you guys do this, okay? You can multiply if they have the same root. They both have the root of 2, so you can multiply them together. Outside times the outside, insides times the insides. So outside times the outside would be negative 3 times negative 4 for 12. Square root inside times the inside. 2 times 4 is 8. N third times n squared is n to the 5th. I'm going to move this because I'm going to have to simplify the inside. So now you guys just simplify the inside. I found a pair, so the 2 comes on the outside, which means you're going to get 2 times 12 for, well, I'll just write them out. So 2 gets to come on the outside. There's a 4 that was a there's a 2 that was a leftover, so the 2 has to stay on the inside. And then now let's do our variable stuff, right? So since this is a root of 2, so 2 goes into 5 how many times? Well, 2 goes into 5 twice, so that means there's going to be n squared because there's going to be 2 n's. So 2 goes into 5 twice, and then there's a remainder. So then just multiply the outsides together. 24n squared root 2n a. Okay, 39. They got the same root, and some of you guys might be asking, well, Mr. Gucci, what does that mean if they have the same root? It's this. That has the same root, which is root of 2. So outside times outside, inside times inside. So negative 4 times negative 1, right, is 4. Square root of inside times inside. 5 times 15 is 75. X to the third times x to the third, x to the 6. Lovely tree. Ew, that is very bad. 25 times 3, 5 and 5. So we found a pair of 2s. Find a pair. So remember, the pair gets to leave, right? So 4 is already out there times 5. Square root of leftover 3. Now let's do our variable. Since this is a root of 2, 2 goes into 6 3 times. So that means x to the third, no leftovers. Simplify, 4 times 5, 20, x to the third square root 3, a. Okay, now we got these ones, alright? Okay. Well, for starters, do you guys see this negative sign? When it's an odd root, which it is 3, you guys can take a negative to go on the outside. Only when it's an odd root. So 2 cube root of 2a to the third all over negative cube root 4a. Just to get it out of the way. So I know that this is really negative 1, right? So I'm just going to put it to the top. So we really got negative 2. Cube root 2a to the third over cube root 4a. Now, this is what I noticed. Do you guys notice how on the top and the bottom, or the numerator denominator, they both have a root of 3, right? Root of 3, root of 3. So that means we could essentially just put them all over one house. Negative 2 is outside, so 2a to the third over 4a. I'm doing this because now we can just cancel stuff. So negative 2 is still on the outside. Okay, so I'm recognizing that. I'll shrink this down. These could cancel, and then really we just got 2 on the bottom because 2 goes into 4 twice. And then I noticed that 1a you can cancel from top and bottom. So really we just have a to the second because we canceled 1a from top and bottom, and we canceled a 2 from top and bottom, so just 2. Now this looks a lot easier to deal with, so negative 2. Now let's break it back up. Cube root of a to the second all over cube root of 2. Now in order to cancel that, or to rationalize the denominator, you just have to get that 2 to be to the third power. So what we have to do is multiply top and bottom by the cube root of 2 to the second. So if we do that, then we'll get negative 2 cube root of, well, 2 squared is 4. So 4 times a squared is just 4a squared. And on the bottom, we're going to get the cube root of 8. And you know you did this correctly if the bot on the denominator it's cube rootable. So we get -2 cube root of 4a squared all over 2. The 2's cancel, so all that's left is negative cube root of 4a to the second, which looks to be a. Okay, 41. So for 41, I'm just going to put them all under the same house. So 8u squared v all over 6u to the third v to the fourth. I could cancel those, a 2 from top and bottom right there. I could cancel 2 u's from there, and I could cancel a v from there, which means we're going to get 4 square root of, so I'm looking at the numbers, right? 8 over 6, you could divide top and bottom by 2. So it'd be 8 divided by 2 is 4, 6 divided by 2 is 3. Okay, you could take out 2 u's from top and bottom, so we'd only get 1 u on the bottom, and you could take 1 v out from top and bottom, so then you just have v to the third. So I would break it up again. So 4 square root of 4 on top over square root of 3uv to the third. Now, in the denominator, okay, sorry, let's focus on the top. Well, the square root of 4, you guys, is 2, so then you would just have 4 times 2. So on the top, you would just have 8. On the bottom, now, I could take out, so remember, this is root of 2. So 2 goes into 3. I'm looking at the v once. So that means we're going to have a v on the outside, and then square root of 3uv. Now, in order to get rid of the square root, we gotta multiply top and bottom by square root of 3uv. 3uv. So equals 8 square root of 3uv all over v square root of, I'll show you guys one if you multiply them together, right? It'd be 3 to the second, u to the second, v to the second. And since this is a root of 2, that root of 2 is just going to cancel all the powers. Then all we have is 8 square root 3uv v times 3uv, which is simply 8 square root 3uv all over 3uv squared, which looks to be d. And let's look how the other one's going. It finished processing. So that means I could put that up. Yay. Alright, but we're almost done here. Alright, 42. Alright, so for this one, you guys, you gotta multiply by the conjugate of the denominator. So that's gonna be square root of 2 minus 4, square root of 2 minus 4. I'm gonna crop that off. So we're gonna move down here. So so when you multiply by the conjugate, right, all you guys have to do is just multiply this one with this one and this one with that one, because the middle terms will cancel. So that's why that's why you're allowed to just multiply the front two only and then the last two only. So we are going to have radical 2 times radical 2 is 2. 4 times -4 is -16. Now on the top, right, so 4 times this one, distribute 4 to both, and then you guys would distribute -√3 to both of those. So on the top, 4 times rad 2, 4 rad 2. 4 times -4, -16. Negative square root of 3 times square root of 2 is negative square root of 6, and negative square root of 3 times -4 is positive 4 square root 3. So that's going to equal 4 square root of 2 minus 16 minus square root of 6 plus 4 root of 3 all over Just put the negative out there, 14. And then basically you would just distribute this negative, you guys, to all of them. That looks like what they did, but the answer seems to be B. Alright, 43. So remember, multiply top and bottom by the conjugate of the denominator. So negative 3 minus square root of 2, negative 3 minus square root of 2. So remember, when you multiply by the conjugate, all you guys have to do is just multiply the 2 on the outside with the 2 on the other outside. So we are going to, on the denominator, we're going to get, so again, only with the conjugates, and when you multiply conjugates together, the middle terms will cancel, which is why only the outer ones will come out. Negative 3 times negative 3 is 9. Okay, square root of 2 times negative square root of 2 is minus 2. Okay, so then you just distribute the top 3 times there to both of them. And 3 root 3 times to both of there. Alright, 3 times negative 3, negative 9. 3 times negative root square root of 2, negative 3 rad 2. 3 rad 3 times negative 3 is negative 9 square root of 3, and 3 root 3 times negative rad 2 is negative 3 square root of 6. So then we just get this lovely top still. You guys get that lovely top still all over 7, which looks to be C. Alright, last two. Okay, so when you guys do, when you solve for these ones, okay, first you have to isolate the radical. So I'm going to add p to both sides. So 4p plus 8 is equal to p plus 3. Now, once you guys isolate the radical, now we can exponentiate. So I can raise both sides to the second power. So a square root and a second power cancels, you guys. So we just get 4p plus 8. Okay, p plus 3, remember, p plus 3 looks like this, right? To the second power. So we're going to get p times p, which is p squared, p times 3, plus 3p, 3 times p, plus 3p, p, 3 times 3, which is 9. I'm just going to simplify the right side just a little bit, combining like terms. Now we just set one side and equal it to 0. So I'm just going to subtract a 4p from both sides first. And then minus 8 from both sides. Okay. Two things I multiply to 1, but add together gives you 2, 1 and 1. So 0 is equal to p plus 1, p plus 1. And I'll solve for p. So p is going to be negative 1. Now, you guys must check your answer by substituting it back into the original. So square root of 4 times negative 1 plus 8 minus negative 1 is equal to 3. Square root of negative 4 plus 8 plus 1 is equal to 3. Negative 4 plus 8, you guys, is 4 plus 1 equals 3. Square root of 4 is 2 plus 1 equals 3. And 3 is equal to 3. That's an answer. C. Alright, moving on to 45. Step 1. Isolate the radical. So subtract 3 from both sides. So we're going to get 5a, square root of 5a minus 21 is equal to a minus 3. Step 2. Exponentiate. Since it's a square root, I'm going to raise both sides to the second power. 5a minus 21 is equal to, remember, a minus 3 is a minus 3 times a minus 3. So a squared, a times a is a squared, a times negative 3, negative 3p, negative 3 times a, negative 3. Oh my gosh, where'd that p come from? Probably from the problem before. Negative 3 times a, negative 3a. Negative 3 times negative 3, it is a positive 9. I'm going to simplify the right-hand side, so we're going to get that. And now let's just set the equation equal to 0. So I'm just going to move everything to the right-hand side. And add 21 to both sides. Ooh. Alright, two things that multiply to 30, but then when added gives you a negative 11. Dun, dun, dun. Negative 6 and negative 5. A minus 6 times a minus 5. A is essentially equal to 5 and 6. I'm going to do it in the order that it came. So remember, check your guys' answer, alright? Check your guys' answer to make sure both of them come up properly. So if a was equal to 6, we would get 3 plus square root of 5 times 6 minus 21 is equal to 6. 3 plus square root 5 times 6 is 30 minus 21 equals 6. Square root of 30 minus 21 is 9 equals 6. Square root of 9 is 3, so 3 plus 3 equals 6. 6 equals 6. Check. And then, if you guys, or not if, when you guys check 5, this is what you guys get. 5 times 5 minus 21 is equal to 5. 3 plus square root of 25 minus 21 equals 5. 3 plus square root of 4 is equal to 5. 3 plus 2 is equal to 5. 5 is equal to 5. So, the answer is going to be D. Alright, so that concludes part 2 of your guys' final mock. Good luck studying, you guys, and I believe all you guys can do it, okay? Peace.